Welcome to this video. This is lecture number 72. Already 71 lecture is covered to solve the supplementary problem of the vector analysis by M.R.Spiegel. You know this book is very important for physics as well as for mathematics and also important for IIT JAM. That's why we decide to solve the supplementary problem of this book. In this video, we want to solve the supplementary problem 7.45 of chapter 7, which consists the Curvilinear coordinate system. So let's start with the problem 7.45, which says that prove that uh, uh, number A, parabolic cylinder, elliptical cylinder and oblate spheroidal coordinate system are orthogonal. You know, to prove the orthogonal, you need to find out the unit vector along the curve, and the unit vector must be perpendicular to each other. This is the need to we need to prove, right? So at first, for parabolic cylindrical, right? For parabolic cylindrical, you know the conversation from this is notation by u, v and z. The conversation with x, y, z, this is the Cartesian coordinate system, is x is half u square minus v square, and y is uv and z is z. This is the conversation, right? So the position vector can be written as r vector is nothing but I cap x plus j cap y, I cap x plus j cap y plus k cap z, right? Just put the I cap x is half u square minus v square, j cap y is uv and k cap z is z. So just want to find out the unit vector along u vector, that is the u curve, along the u curve, unit vector along u curve. This will be del r vector by del u divided by modulus of del r vector by del u. What is the value of del r vector by del u? Just derivative with respect to u, you will get I cap u, and with respect to u j cap v, and this will be 0, and root under u square plus v square. This is the eu cap. Similarly, ev cap will be del r vector by del v by del r vector by del v mod, right? So what is the value of del r vector by del v? If you derivative is this will gives you I cap v, and this will gives you j cap u, and root under v square plus u square, and z, that is the del r vector by del z by del r vector by del z mod. So this is nothing but with respect to z, this gives you k cap, and this is root under 1, that is 1. Okay, we got the unit vector. Now we need to find out the dot product of each case. So uh, eu vector, ev unit vector, if we dot these two, I dot I is 1, so this gives you minus uv, and z dot 1, so this gives you plus uv, and these two are multiply, and this is u square plus v square, root are cancel out. Okay, and you can see this is nothing but 0. Similarly, ev dot ez, if you dot this with this, the ij and this is k, though, so this must be also 0. And similarly ez eu, in this ij and in this k, so this is the dot product also 0. Since these three are dot products are 0, so you can say eu, ev and is z are mutually perpendicular to each other, perpendicular to each other, right? Okay, so you can say this is the orthogonal system, orthogonal system, right? I think clear. If there is any problem, you must comment in the comment box, or you can contact with my WhatsApp number. So let's go to B. For B, that is the elliptical or elliptic cylindrical. Okay, elliptic cylindrical, these coordinates also taken as u, v, z. Okay, and the conversation with the x, y, z as the Cartesian will be a cos hyperbolic u cos v, y equal to a sin hyperbolic u sin v, and z will be z, right? So r vector, that is the position vector, can be written as r vector is nothing but I cap x plus j cap y plus k cap z, right? Put the value I cap x is nothing but a cos hyperbolic u cos v plus j cap y is a sin hyperbolic u sin v, and v, this is v, and k cap z, right? So this is the position vector. Now we need to find out the unit vector along the u curve. This is the del r del u by del r del u mod. So if you derivative with respect to u, this is give you a cos hyperbolic u, derivative will be sin hyperbolic u cos v, and the derivative of sin hyperbolic u is the cos hyperbolic u, and this will be sin v. If you don't how this derivative works, I recommended to go through the playlist. You can also watch the our mathematical class where we prove this derivative, right? And root under, this is the a square sin hyperbolic u sin hyperbolic square u cos square v plus a square cos hyperbolic square u sin square v. ev, this is del r vector by del v by del r vector by del v mod. This is nothing but del r vector by del v. If you derive this v, this will gives you minus I a cos hyperbolic u, and this is sin v, and j cap a sin hyperbolic u cos v, and root under a square cos hyperbolic square u sin v, and this is a square sin hyperbolic square u cos square v, and ez is nothing but del r vector by del z by mod of del r vector by del z. This is gives you only k cap, this is 1. Okay, so if you dot, that is u dot ev, this will gives you, if we dot this in this I1, so this product will gives you minus a square sin hyperbolic u cos hyperbolic u sin v cos v, and this product gives you plus, this is v, and this product gives you plus a square sin hyperbolic u cos hyperbolic u sin v cos v. This is the similar with minus sign, and the root under these two term, right? See, the upper part is cancel out, so this becomes 0. Similarly, ev dot ez, since ev in ij and this is k, so this product also 0, and ez dot eu, this is similar also 0 because this is k cap and this is I cap j cap. So these three are dot product are 0, that's mean eu, ev and ez are mutually perpendicular to each other, mutually perpendicular to each other, right? So you can say this is the orthogonal to each other. I think clear. If you don't clear or any problem, you must comment in the comment box. Go to the next one, that is C. which is offlet spherical spheroidal coordinates, right? Coordinate. Oblate spheroidal coordinate. Oblate spheroidal coordinate. This is denoted as xi, eta, and phi. Okay. And the relation with xyz, that is the Cartesian coordinate system, is x is a cos hyperbolic xi cos eta and cos phi. Y is a cos hyperbolic xi cos eta sin phi, and z is a sin hyperbolic xi sin eta, right? This is the equation. So the position vector can be written as position vector, that is r vector, equal to I cap x plus j cap y plus k cap z. So just put x y z. I cap x is a cos hyperbolic psi cos eta cos phi plus j cap a cos hyperbolic xi zeta cos eta sin phi, and k cap sin a sin hyperbolic zeta sin eta. This is the r vector, right? This is the position vector. This is given as this. So you must find out the unit vector. Unit vector along the xi curve. Unit vector along the xi curve will be del r vector by del xi by del r vector by del xi mod. So if you derivative with respect to xi, so this gives you I cap a cos hyperbolic derivative is sin hyperbolic xi, and this is the cos eta, and this is the cos phi. Okay, plus j cap. This cos also gives you sine, so this is sine hyperbolic zeta cos eta sin phi, and the derivative of sine hyperbolic also cos hyperbolic, so a cos hyperbolic zeta sin eta by root under the modulus of this, right? By root under of modulus of this. I don't write down, this is the this whole square plus this whole square plus this whole square. Okay, and this xi, and this is the eta. For eta, this will be del r cap by del eta by del r cap by del eta mod. So if you derivative with respect to eta, for cos eta, this is gives you minus, so minus I cap a cos hyperbolic zeta sin eta cos phi. This cos also gives you minus, so minus j cap a cos hyperbolic zeta sin eta sin phi, and this sin eta gives you plus cos, so a sin hyperbolic zeta cos eta, and root under this whole square plus this whole square plus this whole square. And the third one is the phi, e phi. So del r vector by del phi by del r vector by del phi mod, right? So if you derivative with respect to phi, this gives you minus, so minus I cap a sin this sin, this is cos hyperbolic zeta cos eta, and this is sin phi, and this sin phi gives you plus, so this is plus j cap a cos hyperbolic zeta cos eta and cos phi, and root under this square plus this square. Okay, no problem. and now you need to dot to each other. So E xi unit vector, E eta unit vector. If you dot these two, just dot these two, I do not want write in the lower side. So a square sine hyperbolic cos hyperbolic in the lower side, a square sine hyperbolic zeta cos hyperbolic zeta. Okay, and this gives you minus, okay, sine eta cos eta minus sine eta cos eta and cos square phi. Okay, and give you cos square phi minus this gives you minus a square sine cos sine square phi. So this is also a square sine hyperbolic zeta cos hyperbolic zeta sine eta cos eta sine square phi. This is sorry, okay, and these two product, okay, and this kk1, so a square sine hyperbolic cos hyperbolic sine, okay, so this gives you plus a square sine hyperbolic zeta cos hyperbolic zeta sine eta cos eta. Okay, you can see if you take common in for first two term, you will get cos square phi plus sine square phi, which is 1. So this is minus and this is plus, so this gives you 0. Similarly, eta dot e phi. So if you dot product these two term, I one, that is a square cos hyperbolic square sine cos, right? So you can write this as a square cos hyperbolic square zeta sine eta cos eta sine phi cos phi, right? I think, okay, this square sine cos, and this will gives you minus a square cos square sine cos. So this gives you minus a square cos hyperbolic square zeta sine eta cos eta sine phi cos phi, and root under dot 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 dot. So this gives you 0. Okay, and another one, e phi dot e xi. So if you dot with these two, so this gives you minus a square and the minus a square sine hyperbolic zeta cos hyperbolic zeta and sine hyperbolic cos square eta sine phi cos square eta sine phi cos phi. Next, as is plus, so plus a square sine cos plus a square sine hyperbolic zeta cos hyperbolic zeta and sine cos, and this is cos square and this sine cos. So cos square eta sine phi cos phi and root under this. So the upper side gives you 0. So you can see these three unit vector are mutually perpendicular to each other. So E xi, E eta and E phi are mutually perpendicular to each other, perpendicular to each other. Since these are perpendicular to each other, so you can say this is the orthogonal system. Orthogonal system, right? I think clear. If there is any doubt or any question, you must comment in the comment box. That's it. This is all about me. This is my contact detail. You can contact with me by this WhatsApp number regarding any physics related question, and this is my YouTube channel details. Go to this channel, you get the videos which already uploaded. Share this video to your friends so that he or she also get benefit from this video. Subscribe this channel if you new in this channel, and press the bell icon to get the notification of upcoming video. Thank you, take care, we will meet in the next video as soon as possible.